Hi everyone, and welcome to your lesson on properties of limits. This is our lesson 1.2 that corresponds to our textbook section 1.2 as well. So if you think about what we've covered so far in regard to limits, the first limit lesson we had introduced us to graphic and numerical approaches to finding limits. This next lesson is all about getting us more into the algebraic side of trying to evaluate limits. So what we'll be talking about today are some properties of limits that you'll see even as we move into the algebraic evaluation of limits. These will definitely come into play. And I think these are very much going to make sense to you. So suppose that C is a constant and the limits of f of x as x approaches a is L, and the limit of g of x as x approaches a is m. And both those limits do exist. Notice how both are approaching the same x value of a. That part's important. So if that's the case, the first property states that if you are then doing the limit of the sum of f of x and g of x, you can take a wild guess as to what it is. It's simply going to be L plus M. If we're doing instead the difference between the two functions, so you want the limit of f of x minus g of x as x approaches a, that's simply going to be L minus M. And the last one involves that constant C that was referenced in the statement of the original properties. So what you're doing is taking some function f of x and multiplying it by a constant C. In that case, the limit in the end is simply going to be that constant C times whatever the limit of f of x was, and that was L in this case. These are very much obvious properties. Don't make them harder than they are. So 3 more. You can probably guess these as well. If you're doing the limit of the product of f of x minus, times g of x, that's simply going to be L times M. If you want the quotient of the two functions and you're doing the limit of f of x over g of x as x approaches a, that's going to be L over M. And of course, if you did g of x over f of x, then that would be M over L. And finally, the last rule, if you're doing the limit of the function f of x and that f of x function is being raised to a power, really all you would do is take the limit L and raise that to the same power. I told you these very much make sense. If you're trying to find these in your book, by the way, you can find these all in our Anton book. It's page 81. So let's take a look at a few practice problems. This is one of the shortest lessons of the entire year, by the way. So suppose, let's see, we have the limit of f of x as x approaches c, and that limit is known to be 3 over 2, and the limit of g of x as x approaches c is 1/2. So the first thing we're asked to calculate is the limit of 4 times f of x. So this is that last property where you're multiplying a function by a constant. So all we would simply do is 4 times 3/2. And that equals 6. Let's look at letter B underneath. So now we want the limit of the sum of f of x and g of x. So we would be doing the limit of f of x, that's 3/2, plus the limit of g of x is 1/2. Of course, that gives us 4/2, which simply is 2. The limit of the product, we're just simply going to multiply the two limits. So we'd have 3/2 times 1/2. So that's going to be 3/4. And finally, the limit of the quotient of f of x over g of x. So we'd have 3/2 over 1/2. So you can think of that as, dividing by a fraction, multiplying by the reciprocal, that whole bit. 3/2 times 2 over 1. So, of course, that gives us 3 in the end. Please don't think there's a catch. There is not. Yes, it's this easy. If there's any lesson I had you to do on your own, this would be the one. So let's take a look at another example. Suppose now we know the limit of f of x as x approaches c is 27, and we want, first of all, the limit of the cube root of f of x. Well, that's the one in which you have the function being raised to a power, because remember, if you're doing the cube root of f of x, that's really f of x to the 1/3 power. So we would have 27 raised to the 1/3, or you could just think of it as cube root of 27, either way. But in either case, that's simply 3. If we wanted the limit of f of x over 18, all we would do is 27, which is the limit of f of x as x approaches c, divide that by 18 and simplify, we get 3/2. Believe it or not, these even do show up on the AP exam in the multiple choice. We hope to see lots of these. If we wanted, this is almost like letter A, similar to it. So if we wanted the limit of f of x squared as x approaches c, that simply would be 27 squared, whatever that is. I don't have my calculator, so we can just leave it. That's fine. And finally, again, another similar one in which you have a function raised to a power. Remember the summer assignment where you had to do these kind of things in your head? This is why. Because you're doing 27 to the 2/3. That would always be something you'd see on a non-calculator part. So remember, the denominator tells you the root that you're doing. So you would maybe start by doing the cube root of 27, which is 3, but then you're squaring the 3. So you have 9. One thing to note is that, because you might see some of this, is that all of these properties, if you take a look at them, they were all as x approaches a number, c in this case. They do work similarly if you're doing the limit as x approaches infinity. So just in case you come across any of those. So what you're going to find in the assignment that you have are really problems like this. Like I said, please don't make them harder than they are. There is no catch. This is it. The only thing I wanted to make mention is that you might see some as the x approaches infinity, but the properties operate the same way that you see here.